Hi everyone. Now in this video, we are going to learn about the addition reactions that happen in alkenes. Now in alkenes, there are five addition reactions that you're going to learn later on, and we also learn about how to predict the products that will be formed according to the Markovnikov rules, and also we're going to see how to predict the product between in the reaction between alkene and hydrogen bromide in the presence of hydrogen peroxide according to anti-Markovnikov rules. Now, for alkenes, alkenes because it is unsaturated compound, it will undergo addition reaction. The pi bond. Wait, yeah. Alright, the pi bond here of the double bond will be broken into two new single bonds. And in the end, there are only one product that will be obtained. Only one product that will be obtained. Now for this, the type of reaction is electrophilic addition. I will explain to you why it is named electrophilic addition in the next video. Now let's see what we have. So when we want to predict the product, we are going to apply what we call as Markovnikov's rules. But this one only when you have the addition of HX and anything related with halogen as well. So as you can see here, the hydrogen atom is added to the carbon of double bond that has greater number of hydrogen atoms. So when we reach to the reaction that involves this, I will explain to you. But for now, let's proceed with the first reaction. Now the first reaction is hydrogenation. Hydrogenation means it's a process of putting hydrogen. So for this reaction, we need hydrogen gas, and also catalyst. And the catalyst that we're going to use here is platinum, nickel, and palladium. So the reagent again that we're going to use is this. We need hydrogen gas and we also need the catalyst. So what will be happen here? What will happen? This double bond here. This double bond here. It will be break and two hydrogen will be added to it. But again, this is very important. You have to add either platinum or palladium or nickel. When you don't add it, no reaction will happen. So from alkene, we can get alkane. Now let's see the example. So for this, we are going to have... usually I will tell my students, go and find two things. Go and find... not two things lah, it's like a tips from me. Two atoms or group of atom that will be added at this site. That will be added at this site. So I like to name this as carbon 1 and this is carbon 2. Now since we are adding hydrogen gas, which is having H and H, we have two H. So what will happen? The double bond here will break. The double bond here, it will break to form hydrogen. To add hydrogen and hydrogen. So this double bond will become single bond. So there you go, we're going to have hydrogen. So let's see this one. Now for this, So what you have to understand, okay, each of these carbon has 2 hydrogen. However, for the carbon here, okay, for this carbon, since it is sp2, therefore it only has 1 hydrogen. So the addition will goes here, and we are going to get hydrogen here, and the addition of the other 2 hydrogen will be here. Okay, so you guys can expand it, or you can just write as this. Okay, you can just write as this skeletal. Okay, you can write like this. Okay, so there you go. This is an easy one. Okay, let's go to the next one, which is halogenation. So the word halogenation means we are going to add halogen, or the process of adding halogen. Now, halogenation has 2 types. We have halogenation in inert solvent and also halogenation in aqueous solution. Now, besides CH2Cl2, another inert solvent that you can use is we have CHCl3, we have CH2Cl2, we also have CH3Cl. We also have all CCl4. So each of the hydrogen will be replaced with chlorine. So this is the inert solvent that you can use, right? So it does not necessarily this one only. You can use the other 4. Okay, the next one is halogenation in aqueous solution. So I'm going to explain what is the difference between both of these. Okay, let's go with the first one, halogenation in inert solvent. Halogenation in inert solvent. So for this halogenation in inert solvent, we are going to use halogen, either chlorine gas or bromine gas, okay, in inert solvent. So again, like I say, it can be any inert solvent, okay, to form what we call as vicinal dihalides. Okay, vicinal tu basically, if I can explain in Malay, vicinal means sebelah menyebelah. Okay, dihalide sebelah menyebelah. So both of the halogen will be added side by side. Now, what is actually happened here? Okay, so again, this double bond will be break up, and this one, it has X and X. And since this one is inert, okay, inert, so it will not involve in this reaction, and therefore both X will be added to it. Okay, so we can directly go to the example. Okay, so here we have propene, and our reagent is bromine. So you have to look, this is bromine. So bromine, we have Br and Br. So both of the Br will be added to this propene. And we're going to get okay, so here we are going to add bromine and bromine. Okay, so here we go, we have this. So as you can see, the halogen both of the halogens were added side by side. Okay, now let's proceed with this. You can pause first and then you can see the answer. So for this one, we are going to get CH3. Okay, the double bond is here. CH3. So what will happen? Okay, this bond break. So we're going to add bromine here. and the bond will break. So you get this. Oh, sorry. Pardon me. It's not bromine. It's Cl. Okay, there you go. Right? Okay, now let's proceed with the next halogenation, which is in aqueous solution. So instead of using what we call this inert solution, in this process or in this reaction, we are going to replace the inert solution with water. Okay, so as you can see here, we have these two, but in water. So this is a little bit different. No, because water is not an inert solution, so it will involve in this reaction. So here we have X and X. And here we have H and OH. Okay, or maybe I can use another color. We use green. So we have H and we also have OH. So we have 4 species to be added here, but only 2 will be chosen. So we will choose 1 each, which means X will be chosen, one of the X will be chosen, and from H to O, we choose OH. So how can we determine which one will goes to which one? Okay, for example, like in this example, we have C, H, H. Okay. So we have carbon number 1 and this carbon number 2. We have X and we also have OH. So you cannot actually simply put the X or the OH everywhere, but in this case, you can put it anywhere because it is symmetry. Okay, so chlorine will be added here and OH will be added here. So this will become single bond. Okay. Now before we proceed, as you can see here, our chlorine, and then you might wonder where is the water. So this is the hint for the water, aqueous. Okay. Now, like I said before, you cannot simply add the X and the OH in any carbon. Okay, so we have to follow Markovnikov rules. So you can see here, given here, bromine and chlorine is added to carbon atom. But I like to, for me myself, I like to think that OH will be added to the carbon with less H. This is how I always remember, either OH or H. So H will be added to the carbon with more H. OH is the other side, opposite. So let's take a look at this example. Okay, now we have this structure H. Let's rewrite it first. Okay, now we have bromine aqueous. So we are going to get 1 bromine and also 1 OH to be added, right? So let's see this. Now as usual, I will put this as carbon number 1 and this is carbon number 2. Now, how can we determine whether bromine will go to C1 or C2, OH will go on to C1 or C2? We have to look at the number of hydrogen attached to the carbon. Now, for the first carbon or C1, as you can see, we only have a carbon, okay, this carbon and this carbon that directly attached to this carbon, okay, only carbon that attached to carbon number 1. But if we look at carbon number 2, okay, carbon number 2, as you can see, we have H and another H that bonded directly to carbon number 2. Okay, and then if you look here, we say OH will be added to the carbon with less H. So, this we can conclude that oxygen will be added here. Okay, oxygen will be added here, whereas bromine will be added here. Hydroxide ion will OH hydroxide will be added to C1 because it has less hydrogen that directly attached to it, to the carbon 1, and then bromine will be added to the carbon that has more H directly attached to it. But don't forget, after the addition, it will become single bond. Right. So that is the first example for unsymmetrical alkene. Now let's take a look at number 2. Okay, for number 2, okay, so we know here it has only CH3. This one only H. So this is your carbon. 1 to another carbon, and 1 to another carbon, and 1 to another carbon. Okay, this is, say I put this as carbon number 1. And then for my carbon number 2, as you can see, we have this carbon attached to 1 carbon, attached to 2 carbon, but this one we have 1 hydrogen. So C2 has more hydrogen compared to C1. Okay, we are talking about directly attached, okay? So, sorry. Okay. Okay, therefore, sorry. Okay, therefore, okay, we can conclude that bromine will be, bromine will be added here and OH will be added here. Okay, sorry, not bromine. This one is Cl. All right, there you go. How to add the species according to the Markovnikov rules. Okay. Now we proceed with the third one, hydrohalogenation of alkene. Basically, hydro refers to hydrogen, and halogen, yes, it refers to halogen lah. So hydrohalogenation means the process of adding hydrogen and halogenation to the alkene. So this process will follow Markovnikov rule and anti-Markovnikov rules. So I will explain the Markovnikov rules first. Now, I will just directly go to the example. Yeah. Our reagent here is HBr or HCl. Okay, HBr or HCl, where hydrogen, okay, or in this case we have, we have bromine, we have Cl, and another one we have H, and this one OH. OH pula. H, okay. So this we have to follow the Markovnikov rules, which says that hydrogen atom is added to the carbon atom with greater number of hydrogen atom. So I will just directly go to the example. Okay, like this one we have H3C, CH, double bond C H H. Okay, and we have here Br, and we also have here hydrogen. Okay, so let's take a look at this. As usual, there will be my carbon 1 and this will be my carbon 2. You have to identify which carbon has more hydrogen. Is it C1 or C2? So the answer is C2. Okay, because it has 2 hydrogen that is directly attached to it. Where carbon number 1, it only has 1 carbon that directly attached to it. Okay, so what will happen? Okay, therefore hydrogen will be added here, whereas bromine will be added here. Okay, so it become like this. It become haloalkane. Okay guys, you can try to do number 2 and number 3. You can pause first and then you can see my answer later. Okay, so for this one we have this one. So we have here H and we also have Cl. So where did they go? Alright, so for hydrogen it will be added here and Cl will be added here. And don't forget, it will become single bond. Okay, and for number 3, okay, here CH3. So actually we have 1 H here. So if we say this is carbon number 1 and this is carbon number 2, we can see that carbon number 1 has more hydrogen. So H will be added here alongside with another H right here. And your chlorine or your bromine will be added here. Or you can actually write it like this. CH3 and then Br without showing the H. You can also write like that. So this is hydrogenation of alkene that follows the Markovnikov rules. For hydrohalogenations of alkene but following the anti-Markovnikov rules, okay, this one only, the reagent is only HBr with the presence of peroxide. Okay, now class ROOR here, R is actually referring to any alkyl group. Okay, alkyl group or H. So if you have, for example, H2O2, okay, H2O2, it is actually referring to HOOH, okay, in this ROOR. So R is actually alkyl or hydrogen. So anti-Markovnikov is the opposite of following the Markovnikov rules, obviously, where the hydrogen will be added to the carbon atom with fewer number of hydrogen atom. And what I want to emphasize once again is that only HBr is used here. You cannot use HCl, only HBr. Okay, so how this reaction goes on, let's see here. Okay, so this one, say this is carbon number 1 and say this is carbon number 2. We have H And we also have, we have, we have H and we also have Br. So where should they go? So since this is anti-Markovnikov with the presence of peroxide, therefore hydrogen will go here. Hydrogen will go here because it only has one hydrogen, and your bromine will go to the opposite side, which is here. And it becomes like this. Okay. And actually, you might think like, what is the difference whether you want to make it Markovnikovs or anti-Markovnikov? It did makes different. Now, as you can see, if I give name to this, okay, if I give name to this one will be 1-bromo propane. Okay, which is this carbon number 1, carbon number 2, and carbon number 3. So 1-bromo propane. But if we go back here, okay, this one, the same direction, but following Markovnikov's rules, this one will be 2-bromo propane. Carbon number 1, carbon number 2, and carbon number 3. So it do makes different, and it makes it having different class of haloalkane. This one will be secondary haloalkane, which is more stable. This one will be primary haloalkane, less stable. Okay, so this is it. Now let's try doing this number 2 and number 3. So we have H and we also have Br. So where did they go? This is carbon number 2 and this is carbon number 1. Yes, hydrogen will go to carbon number 1 and bromine will go to carbon number 2 following anti-Markovnikov. So we have this. Okay, let's take a look at number 3. All right, this is the example of ROOR. It's not H2O2, but this is CH3OOCH3. So what would be your answer? So say this is carbon number 1 and this is carbon number 2. Therefore, hydrogen will goes here and bromine will goes here. Okay, so this is the reaction of hydrohalogenation of alkene, but following the anti-Markovnikov rules. Again, to make it happen, we only use HBr and peroxide. You have to add peroxide to it. Okay, so let's proceed with the next reaction, which is hydration of alkene. So this one as well follow Markovnikov rules, but to make it happen, you cannot just simply add water. We have to add acid as well to make it acidified water. Okay, so this is how you're going to write it, H2O, and then we add H3O+. So which goes to which carbon? Okay, in this case we have H and we also have OH. So this one is following Markovnikov rules. H will go to the carbon with more hydrogen and OH will go to the carbon with less hydrogen. So let's directly go here. So this one. Okay, so as we say H2O, we have OH and we also have H. So this is carbon number 1 and this is carbon number 2. So which one will go to which one? So hydrogen will go to carbon number 2 because it has more hydrogen, whereas OH will go here because it has less hydrogen. Okay, but don't forget again, the double bond will become single bond. So it produces alcohol. Okay, it will produce alcohol as product. Is there any anti-Markovnikov's rules here? No. Anti-Markovnikov's again only apply for HBr with peroxide. So let's proceed. Now let's see. We have carbon number 1, we have carbon number 2, we have OH, and we also have H. So where do they go? Okay, hydrogen will go here because it has 2 hydrogen. OH will go here because it has no hydrogen directly attached to it. So this one become single bond. Okay, let's try number 3. So for number 3, okay, we have here CH3, and of course, actually we have H. So this is carbon number 1, and this is carbon number 2. We have H. No, we have OH, and we also have H. So H will go to carbon number 2, whereas OH will go to here. So you can write it like this. Okay, you can write it like this, or you can make everything skeletal, except here we have CH3 and we have OH. So that's it for all the additional reaction for alkene, and for the mechanism I will show you in the next video. Thank you everyone.